All right, this is a pre-lab screencast for Lab 3, Exploring Visible Light. And a lot of this I'll discuss and show you in class, but there are some things that you can get from a pre-lab that I want to talk about. First off, the setup for the first part of the lab. Instead of a ruler here, you are going to use a meter stick so you have more distance. And you'll have your flashlight and a sheet of paper, a large white sheet of paper that you are allowed to write on. Don't forget to highlight all of the energy forms you observe throughout this lab. So you'll dim the lights in the room. You'll hold the flashlight 10 centimeters above a sheet of graph paper. Observe the characteristics of this beam, noting the circles of different brightnesses. Measure and record the diameter of the outermost beam. So that will look like, when you hold it up, you'll have a very bright, and I'll color it in to designate its really bright part of the flashlight. And then there will be a dimmer circle around the brightest portion. When you make your measurements, all right, you need to make measurements from the dim portion all the way over to the dim portion. All right, that looks like an eyeball staring at me with little tiny ears. But anyway, so there you have it. That's the measurements. Now, feel free to mark on the paper because it's easier to make marks on the paper and then measure it than having to hold up the flashlight and make the measurements at the same time. But use whatever method you'd like to use on that, okay? All right, let's go back to our lab. Now, you'll then move it to a distance of 10 centimeters, 20, 30, 40, 50, 60, 20, 30, 40, 50, 60, 70, all the way up to 70. And then you'll write the diameter of the light beam over here in your data area. Once you've collected that data, you're going to answer some questions about it. You do not need to graph it initially. So we're going to graph it with some spreadsheet software. So you can just look at the data table at first. The graph will come later. Once you've looked at that information, it says, explain the relationship between the beam diameter and the flashlight distance. In fact, see if you can actually come up if there might be an equation that you could derive to explain that, if possible. But just describe the relationship. And then, did all groups in your class discover the same association? Discover why or why not? Well, in order to figure out if you did, what you're going to do is I'll have a Lab 3 Exploring Visible Light spreadsheet set up. And when you finish your measurements, all right, you're just going to go into your Google Classroom. You or your partner, either one of you, are going to put your lab group's data in here. So for example, if you're the first group to log in here and you found that this was 50 centimeters, you're going to put your information in. Then let's say the next one is 60 centimeters and 70 centimeters, etc. And then what you'll have to do is, and notice it averages once you get everybody's numbers in here, it'll give you an average. And what you'll need to do is wait for everybody to input their data and look across and see if you're getting the same basic data for every lab group. And if not, explain why you think that is the case. All right. So that'll be there for you to use. Then the next part is a basic setup that I'll show you in class. But the important part is that you need to draw what you observe in this setup. So if you have, once you've got your data, you're going to do a thing called a ray diagram. And so you'll set over here a white sheet of paper. And I will give you this white sheet of paper, and it's just going to allow you to see, whoa, that's moving on me. That's going to allow you to see the Raise better. Now, you do not draw in the sheet of paper. I just did that to show you that that's something that's going to be there. When you draw yours, you're going to simply draw what the rays look like as they pass through the comb and then move across. They may be straight beams of light. They may be curved beams. They may spread outward. They may spread inward. There's a wide variety of things that they could do, but you just need to make sure that you draw them. The thing is, however, if they are straight lines, then the lines need to be straight. You would probably want to use a ruler at this portion of the lab. Got that? Use a ruler if the lines are straight to mimic what you see down there later. You're going to move along and follow what the lab says. In this case, you're going to actually place a mirror in between the beam or the comb and the other side. If you need to move that white sheet of paper over to this side to see the beam better, you can. And then once again, draw what you see and be as observant and as accurate and precise as you can in your drawings. This talks about drawing a side view, or what we call a cross section. So this is when you take the lenses, the concave and the convex lens that I'm providing you. Just hold them sideways to your eye and take a good look at them, and then give me a basic sketch of what they look like to you. All right? Now, when you get to this portion of the concave and the convex, all right, notice that it talks about look through the lenses at nearby and distant objects. I would suggest you look at the writing on your paper as your near object, and then find something on the wall, maybe one of the posters or something that you can get a good visual of to look at from the far away. Now, things to keep in mind, and you need to write down. Is the object larger? Is the object smaller? Is the object blurry? Is it clear? Is the object upside down? Is it right side up? All of these things are things you should be looking for and then writing down if they happen to come up in the lab. And then, does the distance of the object affect the transmitted image that you see? Once again, is it clear? Is it fuzzy? Is it bigger? Is it smaller? Is it upside down? Is it right side up? And go ahead and explain use those words when you're explaining what you see. Down here, you're going to then place the lens in between the beam of light, goes through the comb, and then you'll have the convex lens. I suggest you put the white sheet of paper over on the other side on both of these cases, so it'll allow you to see a little easier what is happening to the beam. And then for the last part, you're going to use a small flexible mirror, and you're going to place it essentially where the convex or the concave lens is, and you're going to change it from being convex to concave as a mirror, and you're going to look at the reflected light. So the light will be coming through, but instead of passing through the lens, being translucent or transmitted, it will be reflected. And then what you're going to do is you're going to need to draw the ray diagrams as they come back. Now notice, make a ray diagram that illustrates your observations. That is what you've been doing up here, what you've been drawing this whole time are ray diagrams. So you're just going to draw one from scratch. You do not need to put in the perfect little flashlight, etc. But, basically draw it out like with the light, the comb, the space between the tables, and then put in what your image looks like as far as the rays. And that takes care of the pre-lab for this one, and we'll discuss the rest of it that you'll need to know before you start the lab.